Hey guys, so in this video I'm going to be explaining the last two big parts of the report, and that is the reliability and validity of the experimental process, and also explaining the suggested improvements section. Okay, so for the reliability and validity section, the first thing you need to do is provide an overall statement that comments on the reliability of the results of the data that we collected. Now, you've already mentioned that up here in the uncertainties and limitations. So essentially, it's just the overall you start with the overall final statement mentioning the overall reliability of the evidence. So like the aforementioned uncertainties above show that the experimental process lacked reliability. This is supported by the table XYZ, whatever you used. So something along those lines. Provide that final overall statement of what was gathered in the previous section up here. Okay. Now you need to mention that if there was a high unreliability, okay, so a high level of uncertainty in the data, then that's probably because that probably means there was a lot of random errors that occurred throughout the experimental process. All right, so in this section here, we're going to discuss what those errors could actually be. We're going to identify the sources of error after we've made that statement. So the first thing, make that overall statement about how reliable the data was, and then we're going to state, well, what are the exact errors that could have occurred to make those amount of absolute uncertainty, percentage uncertainty so high. Okay, so to do that, I'm going to go through a quick PowerPoint with you guys. So the difference between reliability and validity. All right, so the uncertainties in the data, so the percentage uncertainties, that impacts precision. Okay, precision impacts the reliability of the data, and reliability is how repeatable the experiment is. Okay, and this reliability is affected by random errors. Okay, and percentage error impacts accuracy. Accuracy impacts the validity, and validity is a measure of how correct the results are, and validity is affected by systematic errors. So that is an important piece of information there that you guys can go off and when writing this section. It just will help you get your head around what you're actually talking about here. So the first thing I'm going to talk about, what I want to discuss is random errors versus systematic errors, because you're going to comment on all the different types of errors that could have occurred, have the potential to occur in the experiment, and then obviously then how that then contributed to the overall reliability and validity on the experiment. Okay, so random errors will shift each experiment from its true value by a random amount in a random direction. Okay, these will affect the reliability because they're random, but not affect the overall accuracy of the result. So what that means, a random error is an unpredictable error in measurement or experimental procedure that has no detectable pattern. Okay, so for an example, the measured volume may be too large or too small. Okay, so if we were meant to measure out 10 mils of hydrochloric acid, if we measured exactly on 10 mils in one trial, but measured 10.4 mils in the other trial, okay, and we didn't know, it was just completely random, and that can be, that is a random error. So random errors can be reduced by repeating the measurement and determining the average. Okay, so like essentially what that means is every time I do a trial, so in our experiment you did 3 trials per variation. Every single time you do a trial, you do another measurement, there's potential for a random error. But if you do that over and over and over again, and you do that, you do the same thing over and over, then we reduce the amount of potential of these random errors, because if we then do the same thing over and over, we can clearly see in our trials, okay, if there was something that was out, a discrepancy, okay. So an example of a random error is one of these we call a parallax error. So it's like how you read the measuring cylinder. It depends if your eyes is like here, or up the top looking down, or at the bottom looking up. You're going to measure because of the angle of the observer, the level of water in this, where this meniscus is going to affect, okay, what the actual measurement is. And that might only be like 1 or 2 mils, but when you're dealing with only a small amount of substance, that can still be quite a large impact on the results, okay. And that's obviously random because you might obviously read the measurement from slightly different angles every single time you conduct that trial. So that's an example of random error. Okay, if that's done multiple different times, that's obviously going to impact the amount of uncertainty we have in those results. Okay, which is explaining why if we have a large percentage uncertainty that you guys would have calculated and presented in your process data, this might be one of the reasons for it. All right, these random errors. So how do you reduce random errors? Repetition and averaging. All right, since random errors are random and can shift values both higher or lower, they can be eliminated through repetition and averaging. Okay, so a true random error will average out to 0 if measurements are taken and averaged through the line of best fit. So like, let's say if you conduct that same trial 100 times, okay, because the random error could be higher or lower, it should average out to what it actually should be. All right. So what about systematic errors? Systematic errors are a little bit different. So systematic errors will shift measurements from their true value by the same amount or fraction in the same direction. Okay, these do not affect reliability since they're always the same, but will affect the accuracy. Okay, so they won't really affect the precision, but they will affect the accuracy. All right. So an example is like measurement bias. Okay, if a consistent repeatable error that occurs every time a piece of equipment is used. So this error will always results in measured values changing in the same direction. Okay, so an electronic balance may be incorrectly calibrated or may be used incorrectly. So if a balance or a thermometer or whatever, your stopwatch or something that you're using is not calibrated properly, or you're using it incorrectly, that's not obviously going to be a random thing that's going to be conducted that's going to be affected every single time that you use that piece of equipment, and it's going to create the same amount of error every single time you use that equipment because you're using it incorrectly or it's not calibrated correctly. Okay, so it's going to affect the accuracy overall of the entire thing because every measurement is going to be out. It's going to be incorrect. Okay, so that's systematic error, which is different to the random error if like there's only one thing wrong, and that can be averaged out by doing the same trial multiple times. So how to reduce systematic error? Well, using calibrated equipment. All right, systematic error always pretty much arises from equipment, so the most direct way to eliminate it is to use the correct equipment and using it in the correct way, essentially. So some examples may be like a scale error. If scale isn't correctly used properly, then that's systematic error. And like say a parallax error we've mentioned before. If you are consistently viewing it at the same angle, then it can be systematic error, but if you're changing the way in which you're looking at it, then it can definitely be a random error. Errors arising from the environment, so ideally the control variables are kept constant, but that may be beyond your control, like air pressure, temperature, humidity, and vibrations. So these changes in variables could be both systematic or random, depending on, if that change in temperature was consistent across the whole experiment, or if it went up and down and changed throughout the experiment, then they would be random errors. Reaction time as well, like let's say when you're looking at your stopwatch, when you say right now, the difference in reaction time might be slightly more or less every time you measure something. That's also going to be a random error. All right, so what you guys need to do here for this section is now state what are all the different types of error that could be found in the experiment that you guys did. All right, mention them. So something along the lines of random error could be things like the parallax error on reading the hydrochloric acid. Also on reading the cylinder in the water of how much hydrogen was produced. Okay, we could have some random errors with like inconsistencies when you guys cut the magnesium. All right, and inconsistencies in reaction time when identifying the hydrogen amount at the different time intervals. Okay, or changes in temperature changes in environment impacting the temperature, or accidental agitation. So accidental mixing or agitation in some of the trials when you were putting the magnesium in and unknown that you're accidentally mixing it a little bit, which can obviously affect the speed of the rate of reaction. So these are all random errors. Mention them, okay, and how that can impact. Well, and remember, what do random errors impact? If I go back to here, random errors will impact the precision and the reliability. Okay, so mention all them. All right, these random errors will impact the reliability. You can now mention all the systematic errors there may be. There may not be many of them, but you guys use thermometers, stopwatches, stuff like that. So how could maybe some of them were not used correctly or not calibrated correctly. Okay, the amount of maybe magnesium that was used was more than the amount of hydrochloric acid for some of the concentrations, so it prevented the full reaction to occur. So maybe when you conduct those trials multiple times, all of the results would be off because the scale of the amount of those two reactants mixed together didn't effectively work for a full reaction. Something along those lines. It could be anything, and they are systematic errors which would affect the validity. Okay. So that is what you need to mention in this section here. Let's list them all out. Okay. The suggested improvements, I'll be really quick because it's fairly easy. Now that you know what all of these errors would be, here essentially you're just going to say, well, what can be changed to fix them? Okay, what improvements could be made to the experiment to improve the reliability? So these could be changed to the procedure, changed the data collection process, changed the equipment used. How can we redirect the experiment? So what else can we find? What can we investigate next? And how can we extend it? So how could the experiment be modified to gain more specific and detailed data to provide a greater insight to the same but more refined research question? So how can I do it better, knowing all of these errors that I just found out? Okay, how do I fix all these errors? Okay, so yeah, that's your suggested improvements and reliability of the data. Thanks for watching.